In section 1.5, we're going to look at 5 different angle pair relationships. The first way that angles can relate to each other is being adjacent. Two angles that are adjacent have a common vertex and a common side, but no common interior points. Adjacent angles look like this. If this is angle 1, angle 2 has to use the same vertex and one of these two sides. So I'm going to draw angle 2 right here. So we have a common vertex and a common side. Be careful. We can have angles that share a common vertex, but are not adjacent. 1 and 2 share a common vertex, but are not adjacent. We can have angles that share a common side, but not a common vertex. Angle 1 and angle 2 share this side, but angle 1 and 2 do not share a vertex. We can also have angles that share a common vertex. We'll make this angle 1, but overlap. And when they overlap, we'll call this angle 2. We have some common interior points. They share a vertex, but they are not adjacent. Complementary angles are two angles whose measures sum to 90 degrees. So if I have two angles, I have to be able to take the measure of angle 1 and add sum the measure of angle 2, and for an answer, get 90 degrees. So if I know angle 1 is like 40 degrees, angle 2 has to be 50 degrees. Don't assume that complementary angles have to be adjacent. Complementary angles might be adjacent, but they don't have to be. The only thing that complementary angles have to be is have their sums measure, the sum of their measures equal 90 degrees. Two angles are supplementary if their sum of their angle measures adds up to 180 degrees. So if two angles are supplementary, that means I can take the measure of angle 1 and add the measure of angle 2, sum them together, and for an answer get 180 degrees. Again, don't assume that supplementary angles are adjacent. They can be, but they don't have to be. The way to remember complementary and supplementary. Supplementary, straight line, 180 degrees. Complementary, corner, 90 degrees. Think alliteration. Complementary, corner. Supplementary, straight line. Now our next definition is made up of a couple previous definitions. It's the definition for a linear pair. Two adjacent angles are a linear pair if their non-common sides are opposite rays. So we have to have two angles that are adjacent, so they have to have a common vertex and a common side, but their non-common sides are opposite rays. So if I look back at the picture for adjacent angles, here's my common vertex and my common side, but my two non-common sides have to form opposite rays. Well, opposite rays form a line. So a linear pair is adjacent angles whose non-common sides form a straight line. My non-common sides are opposite rays. A line, 1 and 2, are a linear pair. So in the definition of a linear pair, I automatically know that two angles are adjacent. But again, be careful. Two angles that are adjacent aren't always a linear pair. We also know that angles that form a linear pair are supplementary, which means that if I take the measure of angle 1 and I add the measure of angle 2, I'm going to get 180 degrees for an answer. Again, be careful. If two angles are supplementary, I can't guarantee that they're a linear pair. If two angles are a linear pair, I can guarantee that they're supplementary. And the last definition, vertical angles. You've heard the word vertical before. We're going to give a little bit different definition when we talk about vertical angles. Vertical angles are angles whose sides form two pairs of opposite rays. Well, opposite rays form a line, so vertical angles form two lines. Let's start by drawing angle 1. Well, if I want to make this side an opposite ray, I'm going to have to go in this direction. And if I'm going to make this side an opposite ray, I'm going to have to go in this direction. So the two angles that are vertical are this angle and this angle. Be careful. Don't assume that vertical has to mean up and down, like when we talked about vertical lines. Vertical angles just mean across from each other with two lines intersecting. So if I look at this angle and this angle, these two angles are also vertical, even though in this diagram they look like they're horizontal. Let's look at a diagram that involves all of these angles. Angle 1 and angle 5. Well, here's angle 1, here's angle 5. They share a vertex and a side, which means that they are adjacent. If we look at this picture, they're also supplementary because together they form a line. Well, if I have two angles that are adjacent and supplementary, they have to also be a linear pair. If I look at angles 1 and 2, 1 and 4. 1 and 4 share a vertex, but no common sides. If I look, their non-common sides actually form two pairs of opposite rays. So 1 and 4 are going to be vertical. 3 and 4 share a vertex and a side, so 3 and 4 are going to be adjacent. And if you look, angle 2 is 90 degrees, and this is a straight line, which means that this angle here is also 90 degrees, a right angle. So 3 and 4 together have to sum to 90 degrees, which means that they're going to be complementary. And the last pair of angles, 1 and 3. 1 and 3 have a common vertex, and we have one pair of opposite rays. But the other two sides for 1 and 3 do not form an opposite ray. So 1 and 3 are not vertical. They look like they might be, but they're not. They also look like they might be congruent, but there's nothing in this picture that says angle 1 and angle 3 are going to be congruent. So the only thing I can conclude about 1 and 3 is that they are nothing of each other.